Hey guys, so it's September 15th and we are reaching the end of the introduction to the class and the first assignment and the first couple of topics. From here on, we'll have an assignment and a new topic every week. So I am doing this at almost 5 o'clock, so class starts in about an hour. That's why I want to make sure this is ready for you. The routine is going to be you guys watch the videos along with the going over the study material um, before the topic is covered in the live video conference. So I'm going to give you the video on Blackboard tonight in about, I guess this class starts at 7:30, so 2.5 hours, and then you'll have until next week to watch it and we'll talk about it. So, as you can see, the topic for assignment 2 is conditional logic. I have created some new fiddles, so I'm just going to go through these 3 examples to add as a supplement to the material already on Blackboard. And hopefully this will help you, and also we will go through these in class as well as look at some of the code that the other students have written and field questions and play with different options, and hopefully it'll be pretty easy to learn. So this first example, the first 2 examples here are pretty short. The last one's a little longer. So this first example is the concept of an if statement. So we're talking about conditional logic. Sometimes you'll see it referred to as, like in a textbook or on a tutorial, as making decisions, because it's all about kind of the word if. And take note that usually when you say if, it's followed by a condition that's either true or false. So somebody will say, um, can you drive me over to my friend's house? And they might say like, if you can wait a half hour. And you either can or you can't. So the condition for the action is either true or false. So programming is pretty usually it's pretty intuitive, so it usually follows that type of logical structure. Um, I should note that the structure of the if statement is always this. If um, so these parentheses here contain the condition. So anything in here must be a Boolean value. It could be just a single Boolean value. It could be a single Boolean variable that's true or false. It could be a Boolean expression that's true or false. When we get to functions, it could be a Boolean function that returns true or false. Anything that resolves to true or false can be put there. And in here, inside of the body, you can put as many lines of code as you want. So you can put, 1 line of code here. I'll just pseudocode it. And then your second line of code here, and your third line of code here. And basically, these statements inside, this is the begin, this is the end of the if statement. These instructions inside the if statement won't get executed unless the condition is true. So if the condition is false, the instructions inside of the if statement will get stepped over. And that's it. So pay attention to just the general structure of the if statement. Pay attention to the if, the beginning of the parentheses, the end of the parentheses, the begin, and the end. Everything else is just details. And you can phrase it however you want. You can put spaces there. Some people do this. I mean, all that matters is that you have if, a space. Actually, some people do that. I hate that, but the main thing that matters is that you have if, open paren, close paren, and inside of those parentheses you have a Boolean value so that it knows whether or not to enter the body of the if statement. The body of the if statement is defined as whatever instructions are between the begin and the end. So that's the general gist of everything we're going to be talking about here. That's why I spent a little time on it. I didn't want to start just diving into it without explaining the basic syntax of the if statement. So having said that, hopefully we can just read this intuitively now that we understand that this is just a condition, and if the condition is true, it will enter the body of the if statement, execute all of the instructions. If the condition is false, it will skip them. So we can kind of read this in English almost once we've established that. So it just says if, actually I'll just back up a little. It says, hey, how old are you? And then we gather a number from the user. So we've asked the user how old are they. And this says if the user indicated that they're at least 25, then it will tell them that, hey, did you know that you're old enough to run for Congress? Okay, and if statement number 2, if they indicated that their age is less than 18, we are going to tell them, oh, no, you're not old enough to vote yet. Oh, you're not old enough to vote yet, not oh no, or oh no. Here we have if your age is between 18 and, actually, if it's greater than or equal to 18 and less than 21, that means this one actually means you're old enough to vote, and this one means you're not old enough to drink because your age is less than 21. So if you're old enough to vote and you're not old enough to drink, it says you're not old enough to drink yet, but at least you can vote, which is more important than drinking, obviously. Not really, though. And then this last one is if you're 35 or older, it says, hey, you're old enough to run for president. So the important thing to understand here is that these statements inside of the if statements will only be executed if the corresponding conditions are true. So depending on what the user inputs, so I'm going to run it. Depending on what the user inputs, we're going to get different values. So if I am, for example, 30 years old, what's going to happen? So this is going to be true, so I can run for Congress. This one's going to be false, so it's not going to tell me I'm not old enough to vote. This one is going to be false because, of course, I'm old enough to drink and vote. And this one, did I say 35? Yeah, I think I said 35. This one's going to be true, barely. So it's going to tell me that I'm old enough to run for Congress. And this one is also going to trigger and say I'm old enough to run for president. So it said, did you know that you are old enough to run for Congress? You are even old enough to run for president. That's wonderful. So I can run it again, and this time I could put 34. Again, the two if statements that are about being too young are not going to hit, but also the last one's not going to hit because 34 is not greater than or equal to 35. So now it's only going to say, did you know that you're old enough to run for Congress? Now, what if I put a number that doesn't meet any of these, like 30, or wait a minute, 24? I'm too young for either of the government things to fire, and 24 is too old for these two to fire because both of those are checking to see if I'm old enough to do something, and if I'm not, they print something out. But in this case, I am old enough to do those things, so nothing happens. So that 24 is a good example in these here. So if I want to trigger some of the other ones, did you know that you're old enough to run for Congress? So I already showed you the government ones. How about really young, like 16? Oh, you are not old enough to vote yet. Okay, well, what if I boost myself up to 18? It's going to say you are not old enough to drink yet, but at least you can vote. Well, that's good. What about when I hit 21? I think now I'm in that limbo area where it's not going to show me anything. So I have statements that talk about voting and drinking, and those only really matter up until the point where you're 21. So anything 21 or greater doesn't matter until you hit 25, and then all of a sudden that number matters because you'll see that one. So if I say, 24, nothing will happen. But if I say I'm 25, now all of a sudden it'll be like, hey, did you know that you're old enough to run for Congress? But notice it didn't say I could even run for president. For that, I would have to run it with a bigger number, like 50. So that's basically how the if statement works. I mean, you can come up with any with any condition and any series of instructions that you maybe want to do. Like when I'm in the live class, I usually use the example of, like some very intuitive example, like should I go to Chipotle? Because that's usually what's on my mind when I'm teaching. And I always say something like, well, after class is over, if I'm still hungry and I have enough time, then I will go to Chipotle. So that type of just logical thinking in real life is identical to what you're programming with an if statement. You're saying, based on this condition, no matter how complicated it is, it could be just one thing, like, hey, if I feel like it, I'll go. It could be based on one thing, or it could be based on a combination of things, like I have to be hungry and I have to have enough time, and I have to be able to find my car keys, and so on and so forth. So just based on a series of conditions, they all have to be true. You come to the decision. You make a decision, either yes or no. And a no decision is not doing the stuff inside of the body. Simple as that. Okay, since I went on a bit verbose about the first fiddle there, I'll go a little more quickly with the next one. So this is smaller code, no less amount of code. I do the same thing. I ask the person, how old are you? Now, in this case, I've annotated it's a typical if-else phrasing. So I'll tell you what I mean by phrasing in a second. So notice I still have the basic syntax of the if statement intact, and I just say if you're 18 or older, I'm going to tell them you're old enough to vote. However, I've added something that looks almost exactly like the if statement afterwards, except there's no parentheses, there's no condition. It just says else begin end. So the mechanics of this is, what if you want something to happen no matter what? What if you want one thing to happen if the expression is true, but you want something else to happen if it's false? So the else takes into account that it will the code in the body of the else scope will execute if the condition is false. So what you have here is a condition that will execute, that based on whether or not this is true or false, it will execute either this body or this body. So if the condition is true inside if, it will execute that. If it's false, it will execute that. Now, the programming language doesn't know anything about real life, so you can make claims up here that are, they're just stupid. You could say, if age equals 99, then you're old enough to vote. And in every other case, unless you're exactly 99 years old, you're not old enough to vote. That doesn't make sense logically, but it'll still compile and run. So just because the syntax is there doesn't mean that your logic is correct. So you have to kind of match up the mechanism, the intent of the language artifice, and match it up with your logical intention. So when I think to myself, well, it's basically a coin toss situation when you want to use if else. It's always going to be either heads or tails. You're never going to have a scenario where nothing happens. You always are going to have one or the other, and it just depends on a condition. So that's when you use if else, when there's exactly two outcomes. You're either old enough to vote or you're not. As simple as that. So this is a good introduction to kind of like multiple things happening depending on a condition. Instead of the plain if statement where you just do it or don't do it based on a condition, you have different things that could unfold, different courses of action that could unfold depending on a condition. In real life, this would be something like, maybe you're shopping for a computer and you don't know whether to buy a PC or a Mac, and you decide, I'll buy the PC if it plays my favorite game smoothly and it's under this amount of money. Like all the you're making one decision or the other based on a number of things that all boil down to one condition, which ends up being either true or false. So you make a choice, one or the other. The reason I said phrasing is because there's this thing called the ternary operator. Just to simplify it before I explain the phrasing there, The ternary operator is basically like int x equals, well, I'll just say this, bool b equals true. Never mind that that's always true, but so you have a condition and 10 or 20. So this is like shorthand for an if-else statement. So if you kind of break it down to kind of, by the way, parentheses are usually optional. Like I have parentheses in the next statement, but I don't need them. I could use them here too. I could put them around the condition. I could put them around that value, and I could put parentheses around that value. Maybe that helps to see it a little better. So this whole thing here is one value. It's either 10 or 20. So the question mark is the ternary operator. It's shorthand for if else, and it boils down to a single value based on the condition at the beginning. So it goes condition, question mark, value if the condition is true, colon, value if the condition is false. So it's nice because you don't have to do things like this. I mean, this is kind of long, ugly code, and this is nice. It just says I want 10 or 20 depending on whether or not this that's true, and that manifests in this next line of code that you see here that says this is going to say either you are or you are not old enough to vote. So how do I accomplish that? Well, if we look at what's inside the parentheses, I have a condition, age is greater than or equal to 18, and I have two values, blank and the word not followed by a space. If age is greater than or equal to 18 is false, which means I can't vote, it's going to use this value instead of that one. So it will be you are not old enough to vote. So this line of code here covers both conditions, and the ternary operator is really nice and concise and readable to some people and really ugly to other people. So it's totally, that's why I said phrasing. It doesn't change how it works. It just looks different. And there's like an infinite number of ways to phrase anything that you want to do in coding. So now on to the last example. So it says, please input any number. So we'll get a number from the user. It could be any number. It's a double, could have a decimal, doesn't matter. Now, here I just have a reiteration of what we already talked about in the first example. These are nothing but if statements, plain old if statements. So, the stuff in quotes is just like I said, it's just to like pretty print it or to format it nice. So this just says if it's, if the number is greater than 10, say that it's at least 10. If the number, or greater than or equal to, if the number is greater than or equal to 10, starting over. So we ask the user, please input any number. They give us a number. It's a double, so it could have a decimal. And then we have something that we already talked about, just plain old if statements, 3 of them in a row. The first one checks to see if it's at least 10. Second one checks to see if it's at least 100. Third one checks if it's at least 1,000. Now, since we know from the first example that plain if statements are not really related to each other, all 3 of them could execute. It depends. So each one of them will check the validity of their own condition. So, for example, the number 300, this would be true. This would be true, but this would be false because 300 is not greater than or equal to 1,000. So in that case, only the first 2, if the user typed in 300, only the first 2 outputs would show. And this code is separated into 2 sections. This section here where I say 3 standard if statements, because we're looking at how 3 standard if statements behave. And down here, we say 1 if else chain. So that's the new thing that we're learning in this example. So in the last example, I was talking about when you have 2 situations and one of them will definitely happen. So like flipping a coin, it's either going to be heads or tails. But what if you have more than two situations, or you're deciding on more than two things? Maybe you have four things to choose from. You have to make a decision. Still, you have to make a decision, but this time you have four choices instead of just two. So that's what the else chain is for. So in this case, it's still one if statement. Just like the if else is one if statement, this is all one if statement. And just like if else, only one of these bodies can be hit, because when it was if else, based on the condition, if it was true, it would enter the if block, and it was false, it would fall through to the else block. However, with a situation like this where we have four things to choose from, it will basically go one at a time down the else ifs, checking the condition each time, and if any of the conditions are true, like for example, it will say, we'll follow through with the example we said before. If the user typed in 300, it's going to say if the number is greater than or equal to 1000. Well, 300 is not, so it's going to say this is false, I'm not entering this if block. But instead of just continuing on with the program, it's going to proceed to the next instruction in the chain. It's going to say, okay, it's not greater than or equal to 1000. Well, let's try this. What if it's greater than or equal to 100? And it is. So it's going to print out the number is at least 100. Here's the difference. The difference is now that we have found a positive or a true condition and a positive case, it's going to end. It's not going to proceed with any of the rest of the checks for the if statement. So if you have if you have the series of if statements, they all execute because they're separate statements. But this is one chain where you're trying to make a single decision. It might have four potential outcomes, but it's a single decision. So this is three decisions. This is one decision. That's what I'm trying to demonstrate here. So if I type in 300, all three of these could possibly execute, but only one of these can possibly execute. So let's do that. So as you can see, for the three standard if statements, the first two executed, but the third did not. And in the big chain of if else ifs, it landed on the number is at least 100 and then kicked out. It didn't bother to say it's at least 10 or 10 or smaller. So if we run it again with, say, let's use a big number so that it will hit all three positives in the three if statements at the top. So the number is at least 10, the number is at least 100, the number is at least 1000, and this one just was true in the first condition, and then it didn't bother to check the rest of them, even though all of these are true. The number is greater than 100 and 10. All this stuff is true, but it didn't need to do that because that's the way if statements work. This is one if statement, therefore only one decision or one block in the chain matters. So that's the way it works. And there's one final caveat that I want to explain, and that is this guy right here, this else. So you don't need an else. So I could get rid of that, and we could have this chain here, and it could be possible that we just have three choices. You could that'd be like intuitively that'd be like going to the store and somebody having like a bookstore, and you'd be like, hey, do you have this book? And they say we have three different versions of this book. Which one do you want to choose? And then you would make up your mind, and you could say I don't want any of them, and then nothing would happen. So that's totally that would be the this form here would be the equivalent of you may buy one of the three. You're only going to buy one, but you don't have to buy one. That's if there's no else. But if there's an else, that means you're going to buy one. You're going to buy exactly one, no matter what. So even if none of your conditions are met, you're going to have a fall through default scenario, because else is conditionless. So it's like, well, this thing that I wanted wasn't true, and neither was this, and neither was this, but so nothing I wanted was true, but I still want to do something. So what I've done here, just to make it make sense, is to say if the number is really small, like a 5, then this will be false. It's not greater than or equal to 1,000. This will be false, not greater than or equal to 100. This will be false, not greater than or equal to 10. And at this point, it's going to fall through to the else, and this is conditionless. So this is interesting, the final point, and this is interesting because we know logically by what we have coded that we will hit this statement if all 3 of the previous conditions are false. Now, the language doesn't know anything like intelligent about the previous 3 conditions. I know logically by looking at them, if all these are false, then it must be true that the number is less than or is 10 or smaller. Actually, oh yeah, greater than or equal to 10 will hit this, and I think this one is actually less than 10. Right? The number is less than 10, because if it were 10, then it would hit this. Yep, my bad. See, sometimes doing this stuff is helpful. Oops. So I applied my my human logic. Like I said before, your logic has to be correct as well. I applied my human logic to say, well, I have to do something. What do I do in this last case? And I just used my own the logic within my own brain to analyze this and say, well, it must be the case if it's not greater than 1,000, if it's not greater than 100, if it's not greater than or equal to 10, it's only possible that the number is less than 10. The language doesn't know that, but I know that. That's why, I don't have to say else if number is less than 10. Now, I could do that. And this actually logically will not be any different. It's no different. It will, since literally, if these 3 conditions are false, this condition must be true. But that's just because I wrote correct logic. And since I wrote correct logic, this is redundant. I don't need to say if number is less than 10, because at this point I've already checked every other possibility. So I know the number is less than 10 at this point. So I don't need that. So I hope that kind of makes sense. I'll run it and put in 3, and notice none of the 3 if statements at the beginning ran, but this chain actually went all the way through. It checked this condition, checked this condition, checked this condition, and none of them were true, so it fell through to the else. And that is it. So, like I said, these videos are just supposed to be kind of a transition into the new online format because of the pandemic. I'm sorry if they're not particularly well thought out or too fast, but I'm just trying to get a baseline so I know how fast, slow, comprehensive, or rigorous I need to make them in the future. The last one I know was frantic and crazy. This one I slowed down a little bit, but it was still fast. But like I said, we have all the other stuff on Blackboard to supplement this and our time in class together. So I'll get your reactions from this. I'm guessing you're gonna want me to go even slower in the next one, and I'll try to do that. But it's a balance because the slower I go, the more I repeat stuff that's already on Blackboard, and it takes more time for you to listen to. So hopefully this helped at least a little bit, and I will now start getting ready for class since it's 5:26. All right, see you guys.